Welcome dear all to the clutch module session. In this session, we are going to discuss the types of clutches and the formulas used for calculating the clutch related problems and some sample problems. Basically, clutches can be classified into three types. They are disc or plate clutches, cone clutches, centrifugal clutches. Disc or plate clutches may be either single or multiple disc clutches. So these are some of the diagrams that represents the corresponding clutches. This one, single disc or plate clutch, is the clutch commonly used in automobiles, that is in cars and commercial four-wheelers. So here you can see a pedal, clutch pedal. By pressing this pedal, we are actually disengaging the clutch plate from the flywheel. So by this way, a clutch plate can be either engaged or disengaged by means of this clutch pedal. So since you can see only one disc here, it is called as single disc or plate clutch. Here we can see multiple disc clutches. Multiple disc clutches are getting more common now. Multiple in the way dual clutch transmission, DCT. The cars like Hyundai's, Kia, Tata, Altroz, they are having the dual clutch transmission system, and Volkswagen also. Cone clutches, they are particularly meant for F1 Formula race cars, and centrifugal clutches are designed for lawn mowers, and where the torque is highly required, centrifugal clutches are being used. So this diagram represents a single disc or plate clutch, the cross section. Here you can see several nomenclature. Here the P represents the pressure, R1 represents the external radius, R2 represents the internal radius, W represents the axial force. You can see the axis here. So the force along the axis, axial force, and this R represents the radius, and dr represents the radius of this ring. Here T represents the torque transmitted by the clutch, and we have already discussed P is the intensity of axial pressure. R1 and R2 are the external and internal radius, and mu is the coefficient of friction. And we know that the area of contact surface or frictional surface is given by 2 pi r dr. And similarly, this axial force is given by pressure into area. Frictional force is given by F to the suffix r is equal to mu into small angle delta W. So by substituting all this, we can calculate the frictional torque required. And we know there are two things that is commonly considered for calculating the frictional torque. The first one is considering the uniform pressure. Then the second one is considering the uniform wear. So these are the formulas that is helpful for calculating the frictional torque in the problems. And here you can see a capital R. Capital R means mean radius. So this is, as I already told, we can consider the uniform wear for calculating the frictional torque also. So here the formula C is equal to W by 2 pi into R1 minus R2 is the required one, or W is equal to C of 2 pi R1 minus R2 is the commonly used formula. And here this one is the commonly used formula for finding out the intensity of pressure. So intensity of pressure P, R is the radius, C is the constant. So this formula can be used accordingly. P is equal to C by R, or C is equal to PR. However, when it is required, we can use it. So now we are going to a problem. Here they have asked to determine the maximum, minimum and average pressure in plate clutch when the axial force is 4 kN. The inside radius of the contact surface is 50 mm and the outer radius is 100 mm. So we are asked to assume the uniform wear. So here the axial force capital W is given as 4 kN. We know that 1 kilo is equal to 1000 or 10 power 3. So we have to convert that 4 kN into 4 into 10 power 3 Newton. Similarly, the inside radius of the contact surface has been given. So we know that the inside nomenclature is R2. So R to the suffix 2 is equal to 50 mm. And the outside radius, that is R1, is equal to 100 mm. In this scenario, we have to find out the maximum, minimum and average pressure in the clutch plate. So first we have to find out the maximum pressure. As I told already, the maximum pressure lies in the internal radius. So we can say that P max R2 is equal to C. So this is the common form, C is equal to PR. Since we are asked about the maximum pressure, we have substituted max here. So in the substitute. So P to the suffix max into R2 is equal to C. By this way, we can rearrange the formula. So C is equal to 50 into P max. Since P max is unknown, we leave it as it is. We know that the total force on the contact surface W is equal to 2 pi C of R1 minus R2. Here the W axial force has been given, so we have to substitute here 4 into 10 power 3, 2 pi C. C instead of C, we can substitute 50 of P max, R1 minus R2. It is also given in the problem, so we can substitute directly. On substituting the relevant values, it was found that P max is 0.2546 Newton per mm square. So this is the maximum pressure in the clutch plate when the actual force is 4 kN. Then we have to find out the minimum pressure. So similarly, we have to calculate in a similar way. C is equal to PR. Instead of maximum, we have to substitute minimum here. So P minimum into R1. Since the outer radius faces the minimum intensity of pressure, we can rearrange the formula as P minimum into R1 is equal to C. By this way, we can rearrange the formula as C is equal to 100 P minimum, since R1 has been given as 100 mm. And we also know the formula for calculating the axial force, W is equal to 2 pi C R1 minus R2. Here, instead of C, we can substitute 100 P minimum, R1, R2 given, so it can be substituted. And finally, the P minimum value has been found out as 0.1273 Newton per mm square. Next, we have to find out the average pressure. So average pressure's formula is W by pi of R1 square minus R2 square. Since all the values have been found out, we can easily substitute the values and found out the answer. So the average pressure has been found out as 0.17 Newton per mm square by calculation. Next, this is the second problem. A single plate clutch with both sides effective has outer and inner diameters 300 mm and 200 mm respectively. The maximum intensity of pressure at any point in the contact surface is not to exceed 0.1 Newton per mm square. If the coefficient of friction is 0.3, determine the power transmitted by a clutch at a speed of 2500 rpm. Now we have to understand the question. In the question, it is given as a single plate clutch, first of all. Then with both sides effective. What does that mean? Both sides effective means the contact surface area. The contact surface area, it was effective in two sides. So we have to take the n value, small n value as 2. And they have given us outer and inner diameters. So outer diameter D1. Outer diameter D1 as 300 mm and inner diameter D2 as 200 mm. The maximum intensity of pressure at any point in the contact surface is not to exceed 0.1 mm square, Newton per mm square. So that is nothing but the pressure P. So that is P is equal to 0.1 Newton per mm square. If the coefficient of friction is 0.3, coefficient of friction is represented as mu, that is mu is equal to 0.3, determine the power transmitted by a clutch at a speed of 2500 rpm. We all know that this clutch, the clutch system is meant for transmitting the angular motion. So here the speed is given as 2500 rpm. So we have to convert this linear speed into angular velocity. How it can be done? By simply multiplying 2 pi n divided by 60. So the 2 pi into this is speed 2500 rpm. So 2 pi 2500 divided by 60. By this way we can convert the linear speed into angular velocity. So by substituting the values we got 261.8 radian per seconds. In the question it was given us the intensity of pressure is maximum at the inner radius. Therefore, for uniform wear, C is equal to PR2. C is equal to, the pressure has been given as 0.1 and R2, that is R2 value is given. So we have to substitute the R2 value here. By substitution, we found out that the C value is 10 Newton per mm. And also we know that the axial force can be found out by using the formula W is equal to 2 pi C of R1 minus R2. So we know, now we know the C value 10, so we can substitute here, and also R1 and R2 values are also known. So by substituting all the values, we got 3142 Newton. Our ultimate aim is to find out the power transmitted by a clutch. So first of all, you have to write down the formula. What is the parent formula? Power P is equal to torque T into angular velocity. So since the torque is unknown, we have to find out the torque value by substituting this formula. Here T is equal to N, small n. So this is what I mentioned earlier. So N is the number of contact surfaces. In this problem, it is given us with both sides effective. A clutch plate with the both sides effective. Both means 2. So here N represents 2. And mu value is 0.3, that is coefficient of friction. W is the axial force that has been found out already. R, capital R is the mean radius of the frictional surfaces. So that can be found out by using this formula, R1 plus R2 divided by 2. So these values have been given already. So by substituting all this value, we can find out T value. And similarly, we can find out the power transmitted by the clutch. So power, the unit for power is kilowatts. Unit for torque is Newton meter. So the unit is very, very important for every parameter. And similarly for radius, it is meter. Actually, it was given in millimeter. Either it can be left as it is in mm, or if it is required, we have to convert that into meter. Since the torque unit is in Newton meter, we are converting this 125 mm into meter. Dividing this 125 mm by 1000, we get 0.125 meter. Okay. Next, we are moving into multiple disc clutches. So here, this is more or less similar to the single clutch only, but we are going to study a little bit of nomenclature here. N1, here the N1 stands for number of discs on the driving shaft. N2 stands for number of discs on the driven shaft. The formula remains the same. Torque, for finding out the torque, T is equal to small n, that is number of contacting surfaces that we have discussed already. Mu coefficient of friction, W axial force or thrust, R is the mean radius of the frictional surfaces, that is R1 plus R2 divided by 2. So this is for uniform wear. If it is if we are calculating the torque for uniform pressure, then we have to use this formula, 2 by 3 of R1 cube minus R2 cube divided by R1 square minus R2 square. So we are considering a sample problem here. A multiple clutch has 5 plates having 4 pairs of active friction surfaces. So here itself that N value comes, a multiple disc clutch has 5 plates. So we have discussed now only N1 is the number of discs on the driving shaft, N2 is the number of discs on the driven shaft. So all put together only it is the total number of discs. So N1 plus N2. So here it was given a multiple disc clutch has 5 plates. So we have to consider that as N1 plus N2 is equal to 5. Having 4 pairs of active frictional surfaces. So how many pairs of active frictional surfaces are here? 4. So N is equal to 4. Suppose if this value is not given, then there is a formula for finding out this N value. Simply we have to add N1 plus N2 and we have to substitute minus 1. So that is the n value. Positively, here the n value has been given. This problem. If the intensity of pressure is not to exceed 0.127 Newton per mm squared. So you all know that this is nothing but the P value. Find the power transmitted at 500 rpm. So this is n value. Because again you can see here it is given in revolutions per minute. So we have to convert that into radians per second by multiplying by 2 pi n divided by 60. So n value is 500 and divided by 60 we will get in seconds, radian per seconds. The outer and inner radii of frictional surfaces are 125 mm. So it is in this problem they have directly given the radius value. So outer radius value is 125 mm. So R1 is equal to 125 mm. Inner radius value is 75 mm. So R2 value is 75 mm. So we have to assume the uniform wear and we have to consider the coefficient of friction as 0.3. Okay, this is also a very simple problem. It's a direct problem also. So since the intensity of pressure is maximum at the inner radius, we can substitute the C is equal to PR formula as C is equal to P max R2. So this is the direct substitution. All the values are already given in the formula, in the problem. So C value has been found out as 9.525 Newton per mm. I suggest you to, these problems has been taken from Kurumi book. So I suggest you to use your calculator and verify the answer. We know that the axial force formula W is equal to 2 pi C of R1 minus R2. So since the C value is known, we can substitute directly, and also R1 and R2 values are also known. So direct substitution only. And since in question it was given uniform wear. So for uniform wear, the R formula is R1 plus R2 divided by 2. So use that formula and find out the mean radius of the frictional surfaces. Now torque T is equal to small n into mu WR. So you know this formula, right? T is equal to n mu WR. So direct substitution, find out the torque value. Unit for torque is Newton meter. And similarly find out the power transmitted. P is equal to T into angular velocity. That is torque into angular velocity. So unit for power is kilowatt. Just verify the answer by using your calculator. We are moving to the next problem. A multiple disc clutch has 3 discs on the driving shaft. So driving shaft represents N1. Number of discs on the driving shaft, N1 is equal to 3, and 2 on the driven shaft. So number of discs on the driven shaft, N2 is equal to 2. The outside diameter of the contact surfaces is 240 mm. So outside diameter has been given. So D1 is equal to 240 mm and the inside diameter D2 is equal to 120 mm. So we have to convert the diameter into radius by dividing it into 2 by 2. Assuming uniform wear and coefficient of friction as 0.3. So we have to assume the uniform wear conditions here. Coefficient of friction mu is equal to 0.3. Find the maximum axial intensity of pressure between the discs for transmitting 25 kilowatts at 1575 rpm. So here the power value has been given, and similarly similar to the previous problems, here the capital N value has been given. So we have to convert this speed, linear speed, into angular velocity as usual. So omega is equal to 2 pi n divided by 60. That gives 165 radian per seconds. Power value has been given in 25 kilowatts. We have to convert that into watts. So by multiplying with 10 power 3 watts. As usual, we know that the power transmitted P is equal to T into omega. By using this formula, we can find out the required torque. Since the power has been given in this problem as 25 into 10 power 3 watts, and we have find out the angular velocity, T value has been found easily. So it was found out as 151.5 Newton meter. Please check the values with your calculator. And the question, you can note that the small n has not been given. I have mentioned the previous problem. If that value is not provided, we can find out the n value by using this common formula, n1 plus n2 minus 1. So N1 is the number of discs on the driving shaft, that is 3. N2 is the number of discs on the driven shaft, that is 2 minus 1, that is 4. So n small n value is 4. And for uniform wear, in the question we have to assume, we are given that it is given that we have to assume the problem as uniform wear. So for uniform wear conditions, the mean radius of the friction can be found out by using the formula R is equal to capital R is equal to R1 plus R2 divided by 2. R1 value and R2 value has been given in the problem itself. So by substituting all the values, we got 90 mm, and while converting that mm into meter, it was found to be 0.09 meter. And we also know that the torque transmitted T is equal to N mu WR. You know this formula, we are familiar with this. So torque has been found out earlier, and N is also found out. We know the mu value, and only a value that we are unknown is the W value, axial force. So by substituting all the remaining values, we got axial force W as 1403 Newton. Now we have to find out the maximum axial intensity of pressure. We know that C is equal to PR. Also, we know that the maximum intensity of pressure lies in the inner radius. So R2, substitute R2 here. PR2 is equal to C. By rearranging the formula, we get C is equal to 60 P Newton per mm. We also know that W is equal to 2 pi C R1 minus R2. Formula for axial force. W has been found out as 1403 here, and C value, instead of C we can substitute 60P. R1 and R2 value has been given in the problem itself. So by substituting all the values, we got the P value as 0.062 Newton per mm square. So I believe that this session will give you some insights on solving the clutch related problems. Thank you.